I'd like to introduce our next speaker. Our next speaker is David Turner, and David is the ecology subject matter expert at the Terrestrial Ecosystem Research Network Eco-Informatics Facility and leads the data analysis and modelling team. And David is going to be talking to us about ÄKOS, a new paradigm for discovery and access to complex observational data. That's Dave.
Okay, is this on? Yeah. Thank you for coming along. This is going to be a little bit of a different presentation. It's going to be a little bit business, a bit technical, and possibly a little bit controversial depending on how I go. So firstly, just acknowledgement to all of my team out there. Sort of this is very much a multidisciplinary approach to dealing with the problem. So no one person's got the knowledge in their head. We've got people with all sorts of different backgrounds coming together to work on this. ÄKOS itself, it's part of the Turn group of companies, so to speak. And what we're actually on about is it's about reuse of information. It's about reuse of ecological data. So we're not so excited about getting a few metadata records into repositories. That's a step in the right direction, but we don't believe we've achieved our goal until ecologists are actually reusing this information and repurposing it, publishing it, etc., etc. That's when we think we've succeeded. Everything else is stepping stones. So right from the start, we thought about this. This is not an IT challenge. This is a business challenge that has quite a significant IT component into it. And so we went straight away to look at our user community, and this is what we found. Not surprising, most user communities would say something similar. If you remember back to day one when Dr. Jacobs was talking about EarthCube, and he made the statement that according to the National Science Foundation over there, that researchers spend about 80% of their time trying to find data, to get hold of that data, to try and understand that data and to reformulate all those bits into a format that they can actually use. 80% of their time doing that, which is a lot. And so we thought anything we can do to accelerate that process, to speed it up, is obviously a good thing, because that's the bit most people don't actually enjoy. We are dealing with ecologists. Ecologists aren't really computer savvy, and they don't want to spend a lot of time reading through manuals and things on how to use systems. So the systems have to be easy to use. They have to be intuitive. We also need to recognise that every single one of our users wants something completely different. So we can't have a standard, so to speak. So just to give you a bit of a background, Ecology 101, so to speak, ecology is the study of nature. So it's all of that natural stuff going on out there. It's a very, very, very broad discipline. You can be looking at plants, animals, the soil, the climate, everything. All of these things interacting, that's what ecologists tend to work on. It's complex, and by complex I don't mean it's really, really hard, but what I mean is ecosystems, when they come together, they have emergent properties. So they're context specific. You can only understand what's going on if you understand the local context. You have to understand how the observation was made, why it was made, what environment it was in. If you don't have that knowledge, you can't interpret the data properly. There's also this fragmentation, because most ecologists work with very simple tools like notebooks and pencils and things. Everyone does their own thing. We don't need to collaborate and share a Hubble telescope or something. We can all do our own thing. So all of these different methods are different. So you've got massive fragmentation of data happening. And it's a rapidly evolving discipline. So things are constantly changing. As soon as you design a system, you can guarantee that someone started collecting something differently that's going to bugger it up. And it's dispersed. Because they're all individuals, our standard data management platform is Excel, sitting on personal computers, that sort of thing. We've heard these problems plenty of times before. So we've got this idea of an information model that says the data itself is actually only a very small component of what you need. You actually, in order to interpret the ones and zeros, you also need all this context. You need to understand the methodologies, what was done, why it was done, how it was done, who did it, all that sort of stuff. You also need to understand all of those information models that went into it. taxonomy, the classification of the living organisms, the classifications of the various things, boundaries, political boundaries move, all of those types of modelling problems need to be understood and put into context. You also need the actual supporting knowledge of the whole discipline. The theories that went in to the way you actually undertake the observations are very important. You need to have this whole sort of umbrella of information managed together if you're going to actually successfully reuse the data. If you don't have all this information, then what you actually end up with is this concept of data entropy. So an individual researcher goes out, collects some data. It's all fresh in their head. Most of that interesting contextual information is exactly that. It's stored in their head or it's stored in notebooks. It's not tagged to the data. And what that means is over time, it gets lost. It gets forgotten. So the value of the actual data basically degrades over time until it's basically worthless. And that's for the original researcher. Imagine someone else that wasn't actually involved in the project trying to actually understand all that stuff too. So this is a major problem in this discipline. Traditional data management, this is something that was put together by our high-performance graphic team, so I hope you appreciate the effort that went into it. Basically, traditional data management, and when I say traditional, this is current best practice in pretty much every state agency managing large ecological data sets. So what they do is the smart bot goes out and they build a database to store the data. Over time, the ecologists start collecting different data. So what they do is they start shoving things into the comments field and all that sort of stuff. I'm sure you guys are all familiar with that. Over time, the methods drift. Additional data, etc., etc. So you start shoving what you can into the database. Oh, we don't use the soils field anymore, so let's start shove the climate data into the soils field. That'll do. It stores it. What doesn't go in gets stuck in a filing cabinet or on a disk in someone's drawer, that sort of stuff. And then you basically rebuild the whole process and you go round and round and round in circles. That's obviously not a good solution. That leads to this paradox. Essentially, IT, you need, from an IT perspective, you need these rigid models to model the data to store it in a way that you can. And that's because software is not intelligent. It basically needs these fixed structures. In contrast, because the information's evolving, you need actually flexible models and you need to actually be able to store full rich context. And in order to understand that data, it's not just about delivering the data, it's about delivering the knowledge you need to reuse it. So you need to understand all of those subtleties. And you need to understand that the end use of the information is going to be dependent on what the person's question is. So you can't model the data in one way and expect it's going to be useful for everyone. So what we're actually proposing is we throw out the whole concept of traditional data management, relational databases and everything in this field, caveat emptor, and we go to a process where we actually start managing data as rich documents. So store the data, all that context, everything together. For the nerds in the room, a sparse, semi-structured, graph-orientated knowledge model is what it is. But to the lay people, that means that you've got all these pieces of information and you just join them together with lines or whatever you want to say how they're related to each other. And you need this extensible model. I won't use the O word to scare you, but I'll get back to you a bit later about what that all means. We also need to recognise that we need to partition this problem. Not everything's about modelling formally things. Most of the context information is not around formal modelling it. It's around delivering the knowledge. It's around delivering understanding to the end users. So why bother to model those things formally when a simple document that explains it in English is just as useful? The people doing this interpretation are human beings. They want a human readable format, not some sort of fancy arcane sort of structured markup language. And by capturing this full richness, you guarantee that whatever the future use is, you've got the knowledge in the system to best be able to translate it to what they want. So our approach is essentially we take the original data, we map it to this common information model that I was talking about, we bring in all this contextual information as sort of structured descriptions, and then we go through this bizarre ETL, extract, transform, load type process where you basically enrich the information, map it to this common model, and you stick it into the database. We're sticking it in pretty much as documents. So those of you that were around this morning got up early enough to listen to Professor Shaw's presentation. He talked about all these interesting imagery artifacts and how he tags them with traits that make them accessible and discoverable to the end user. We do the same thing. We pull out these traits that are going to be of interest to the end user. So species names, locations, methods, etc., etc. We pull out all this stuff to make the stuff discoverable. In terms of user experience, once again, it's not going to be high tech. It needs to be something that is either familiar to the end users or it's got to be intuitive enough that they can just follow it through. So, I mean, when we put this up initially, one of the people I work with went, oh, look, it's realestate.com for ecologists. And that's pretty much what it is. So on the left-hand side, you've actually got your familiar types of search processes. You've got drop-down boxes. I want to search by this topic. And you can choose things from a controlled vocabulary. That gets rid of the keyword bingo type issue that you get often with these types of search indexes. And by combining ands and ors and these different things, you can actually build up a very, very complex search string so you can filter your data to where you need to go. Your initial results that come up, they're a summary. And they're not just a random summary. They're actually a very, very carefully crafted summary, and it's designed to provide you with the pertinent details you need to make a decision. And the decision is, most of the hits you get are probably not going to be useful to you. So you want to spend as little time as possible knocking out the ones that you should ignore to concentrate on the ones you need to know. So you need to pull out the key features of that. You also need to pull out things like access and licensing. If something's restricted and you don't want to go and do the negotiation, move on. If something's open access, you want to know right up front that you're going to be able to hit the download button today. And these are the types of things going in. Once again, compliments to our graphic artist. This is the ontological model very, very quickly. What we do is our common information model mimics what ecologists do in the field and how they understand data. Ecologists go to sites. They visit the site. They collect data about the site. They have sampling units. They measure all these different things. So when we actually model that information in the system, we don't model it in terms of columns of data. We model it in terms of an artifact that mimics reality. That's what we do. And we can build these graphs that sort of try and implement that. We can have a process view that talks about the methods they used, and an observation view that talks about the actual things they saw and what properties those things had. We also align concepts. So across Australia, across the world, different concepts are in use for different things. Even something like taxonomy, which there's an international society looking at aligning taxonomy. In Australia, we've got 6 different taxonomic schemes, one in each state, basically. And so you've got to basically align these things so that when the end user's looking at it, they can see whether 2 concepts are different, similar, or identically the same. And when it comes to similar, you can point out to the end user how similar they are, and they make the decision whether they're the same or not. We don't make that decision. So in terms of those descriptive artifacts I was talking about, once again, they're not fancy modelled products, they're just structured pieces of information. So we break it down into bite-sized chunks that the end user can actually distill very, very quickly. Each one, so for each methodology we have, you have a basic purpose. Why did you do this? This thing measures the height of a tree, or this thing is used to establish my field site, whatever it is. A very brief synopsis that has all those really, really important details that are like deal breakers to know whether you should be reading on or not. So generally, before you get to the end of this top section, you already know whether it's worth your while reading the rest of the document. If you want to go on, you can go into great detail and actually read every single step. So this is actually a method manual for you to actually go out and repeat the work yourself if you want to, or at least close your eyes and imagine you were the ones that did the original work. The outcome of all this is we're actually hoping that we're going to pull all of this dispersed ecological data, which South Australia alone, estimated Department of Environment there estimates they've got about $150 million worth of environmental data they manage. You multiply that by the number of states in Australia, taking your CSIROs of the world, your universities and things, we're talking about gazillions of dollars worth of information out there that we can potentially pull in together in a national consistent way to allow people to actually work with it. Just a brief snapshot of some of our collaborators that's working on this. So we don't own any data ourselves. We have to go to our data custodians and we have to pull them in, and they need to provide us with the information we need, not just the data, but all of that context. So it's quite an involved process. That's just a few of them there. So it's getting quite difficult to manage all of those relationships. And I'll stop it there and thank you all. A few contact details. Happy to take questions.
Could I encourage you to use the microphone so that we can capture that, and mention your name and your affiliation as well? Thanks.
Hi, David. Thanks for that. It was great. My name is Mark Gagan, University of Auckland. Really keen to know how your ecological researchers respond to these ideas. They resonate with me, but I'm wondering how they respond.
Okay, so I guess there's several responses from ecological researchers trying to get hold of data. They think this is wonderful, and they've already said to us, this is actually the information we need to make those decisions. If we don't have this information available to us on the screen, we have to go back to whoever collected the data and ask them questions and those sort of things. So from an end user ecologist perspective, it's great. From an ecologist who's actually out there collecting the data's perspective, it's a little bit more mixed. So we get the classic, it's my data, no one else on the planet understands it, it's my IP, all of that sort of stuff. But we also get others that realise that, well, maybe there's IP for the first 12 months, but once I've got my publication out, this becomes a really useful tool in preserving that data. Because if you remember back to that entropy side, even if you are the originator of that data, you will forget those details over the time. If you decide to go into another discipline, you're probably not interested. So this acts as a preservation thing. Sorry? You'll forget in 3 days. Knowledge keeps no better than fish. Well, that's right. Exactly. Exactly. Generally positive. Probably the biggest challenge we have is it's a lot of work to actually populate the information you need to actually richly store it. I would argue that if you spend 10 minutes filling out a metadata field, you've wasted your time, because no one's going to be able to understand from a 10-minute spool what that data is about on its own. It might be enough to start a conversation, and that's great, but if that's all you've got to go for, it's a waste of time. You really need to invest the time to do it.
Mark Thayer from Griffith. You do a lot of work so that the modelling of the information represents in a way that the end users perceive the data. When you build your user interfaces and things like that, are you trying to build them in ways where you'll be able to redeploy it, or are those functional components tightly linked to the underlying representations?
No, the way we're actually building it, the actual front end you see is completely agnostic to the underlying information. So by the way, this technology is all open source, so if anyone's free to pinch it. You could actually redeploy this for sociology, for medicine, or whatever other discipline. The way it works is at the heart of that ETL process is a domain-specific language script. So what we've actually done is we've created a system where people that understand the domain, i.e. ecologists and ecological data managers, manage that process. They're the ones that do the mapping. They're the ones that actually tag the information and work with it. So what we actually, and everything in the portal is driven from there. So if we want to change our information model, if we want to change what actually appears in the portal, it's a matter of just adjusting those scripts. and they're written to be rereadable. One of the major problems with ETL is often it's some sort of Java initiative and things, and if you come back to it 6 months later, you go, I don't understand this. So we spent a lot of time building a structured language that you can come back to, you can interpret and say, I need to edit it in the following ways to change the behaviour. So it's fully flexible in that respect.
So if there are no further questions for David, I'd like you to thank him again. Thanks.